Hi everybody, this is an overview of a presentation I gave at the 36th National Narrow Gauge Convention held recently in Augusta, Maine. The topic was using metal shelf brackets for benchwork. When I started this layout, I wanted to have a big layout, and the best way for me to get what I wanted was to go with a multiple level design. I've read a lot of articles in magazines and a few books about it, and seen some home layouts that had multiple levels to them, and this was the way for me to go to get what I wanted in the space that I had. After the track plan was drawn out and pretty much finalized, I began to look at what to use for benchwork. I didn't want rods coming down from the ceilings or legs coming up from the floor. I didn't want anything blocking the view of the scenery. I began to look at metal shelf brackets, and this is what I found. Basically, there's three different types of metal shelf brackets, and they all have some things in common. They're lighter to get home than all the wood you would need to build the same benchwork in wood. You can use the same simple hand tools that you use for wooden benchwork. The metal brackets all have the holes pre-drilled. The metal brackets can't warp, which is always a plus. They're faster to get up and have ready to go, and they come in a wide variety of widths. The drawbacks are that running wiring can be a challenge, and locating things like turnout controls and turntable pits and rivers, scenery below track level, those kind of things can be a challenge. The three basic types are, this is the heaviest of them, this is a heavy duty shelf bracket. This is the strength right here. You don't need one of these for every 16 inches or so. You could probably get away with spacing these about 4 feet, maybe even longer if your layout isn't too wide and it's light and it's supported enough by the wood framing that you have above it. If you have a modular layout that you want to set up at home, this would probably be good for that. The downside is you need one of these brackets for every level, and as you can see, there's a lot of depth here, so there's a lot of space between the levels you would need to have. Next up are the familiar stamped metal shelf brackets. They've been holding up family pictures for decades now. These are the cheapest. They're good for narrow areas. The downside to them is they're small size. They don't really come in large size. They're the weakest, and again, you need a bracket for every level. Third up is the twin track system. They're brackets like this. There's a vertical piece that gets screwed to the wall, and it's basically tab and slot. The vertical piece has slots in it. You drop that in there, slip it down like that. That's it. It's done. Okay. These, if you're building a layout with 2 or more levels, this is much more cost effective than using wood. And while you're building the layout, you can just take this, drop it in, use it for a shelf. When you're done with it, you can take it out and you're good to go. The downside to these really is that the slots on the vertical pieces, the spacing is set at 1.25 inches apart. So when you want to move this up to the next level, you jump up 1.25 inches. If you're building a layout with different grades from one level to another, you're going to have to add wood to bring this up to whatever level you want until you get up to that 1.25 inches, and then you can step up to the next size. For my layout, I decided on the twin track system. My ceiling height here is just a little over 7 feet. So the thickness of everything, or the height of it, was a big factor in everything. There are a lot of switching areas, so most of the benchwork is level, but the levels are connected by something that I call a non-helix helix, which I'm not going to get into in this video. The vertical pieces come in 24, 48, and 72-inch long pieces. For my layout, I use the 24 and the 48-inch pieces, and I use the brackets. I use the length according to what I needed. To get started, I drew a level line around the room. I happen to have a laser transit that I use for work, so I use that to draw the line. You can also use just a laser level. At worst case scenario, you could just use a regular carpenter's bubble level and use the longest one you can. If you're using a carpenter's level, I would suggest rather than starting from one point and working your way around, work from one point and work your way around this way, and that'll help to minimize any fluctuations you might have in there. if your room is narrow and you have a long enough level, you might want to go from one side of the room to the other, just to reference yourself, just so you make sure that that line is level, because everything's being built off of that, so you want that to be as accurate as you can. When I was done with that, I went ahead and I had to go out and mark out all the locations of all the studs on the wall. You want to be as accurate as you can with that, because when you put the screws in for the vertical pieces, you want to make sure you're in good solid wood. You don't want to end up catching the side of the stud where at some point later the bracket could pull out of the wall. When I put them up, I would suggest, this isn't what I did, but I would suggest it, take my word for this, I would pre-drill the hole for the top of the vertical piece. Screw that in, use a level to make sure the upright piece is plumb, then screw it in at the bottom hole. The 4-foot pieces have 4 screws for attaching it. The 2-foot pieces have 3 screws for attaching it. And the reason for that is you don't want them to start wobbling side to side. Once you get the top and bottom in, you put the center pieces in. The center screws in, rather. One thing to be aware of, and I didn't notice this until my layout was done. If you look at this picture closely, the distance from the top of the upright to the top of the slot is slightly less than 1/4 of an inch. Okay? On this one, the distance from the top to the top of the slot is slightly over 5/16 of an inch. Now, that's not much, and there may be a top and bottom. These weren't made to build layouts on, I don't think. I don't think the guy had that in mind. But depending on what your layout is, you might want to measure these before you put them up and adjust your height accordingly, because you don't want to have an easement on the grade going down, having end up being like a roller coaster, or have a large yard with free rolling cars where everything starts dipping to one spot. Just something to be aware of. For the screws, just to step back a minute here, for the screws that you use to attach the upright to the wall, I used these screws that I used. The head of the screw actually stands tall of the upright piece, so it would interfere with the bracket. If the bracket was going to be located in this slot here, this screw would be in the way. When you get the screws, the metal upright piece has a recess for the screw to go into. Make sure that it sits inside that, and you want to use screws that are about 2 inches long. Okay? Once you're done with that and you worked your way around the room, you should have something that looks similar to the wall, similar to this picture here. And you'll notice that in the corner here, I have an upright bracket in the corner, but I don't have one here, because this bracket here, this upright will have a bracket coming out and supporting that. So you don't need to have a vertical piece or brackets at every corner. Okay? When you're done with this, when you put your horizontal brackets on, you want to put these up and you want to make sure that this is level. If it's not level, you can file the bottom here and work slowly, and it will bring the aisle side down. If it's already down, you could do one of two things. You could try it on a different upright and make sure it's the bracket, or you can just shim this side up once you had the plywood on there. There's probably at least 80 brackets on this level, and only 1 or 2 of them were a problem, so it's just something for you to be aware of. Also, when you go around, you have all these brackets in. You want to make sure that you don't walk into them or anybody else walks into them, because if you do, there's a lot of leverage against this, and you could bend this end up, or worse yet, rip the bracket out of the wall. So you may want to take them down if you're not going to be working in that section anytime in the near future. Okay, my original plan was to use ground throws and frog juicers to wire the turnouts up. Then I could screw the plywood directly to the brackets. This is what we're calling Plan A. Now, as you can see, The wiring for the DCC and the sub buzzes and the main buzzes would have to be run underneath of the brackets. In doing that, the wire is running about 16 inches from one bracket to another, and then going underneath the here and back up and over, I'm adding about 5 inches. So I'm adding about 30% more wire. So I was concerned with that as far as voltage drop. So that option wasn't, we didn't go with that option. That would leave me a few other options for running the wires and keeping them up close to the plywood and out of sight from the lower levels. Option 1 was to drill holes through the brackets. Now the layout's built in panels, and I'll explain that in a little while. Each panel has the main buzz, 2 main buzz wires going through. Each panel has its own sub buzz, so there's 2 more holes, and then it also has 2 holes drilled for accessory wires. So that's 6 holes, but this is double-sided, so it's 12 holes. Once that was done, I had to either put like a rubber hose or a plastic hose or something in these holes so that I didn't chafe the insulation off the wire. That was just too much work. That idea wasn't going to fly, so I didn't go with that. Option 2 was to take a router and router a groove or a kerf from one end of the plywood to the other for each of the 6 wires. The problem I had with that was I paid good money for 3/4 inch plywood, and I was basically now cutting it down into almost 1/2 inch plywood. And my concern was that it would warp either this way or that way. So that plan went out the window. The next plan was a variation of that by just cutting kerfs above where the brackets would be. I would still have to do something with the metal up here. Even though it's painted, I would have to put something there to stop it from chafing against the wire. The problem with that is that each bracket would have 6 wires going over it, and for every 8-foot section there's 6 brackets. So I would have 36 places to try and fit wire in there. It was like herding cats, so that idea went out the window. Next up, following a friend's advice, I went ahead and he had suggested that I use some dimensional lumber to add some stiffness and rigidity and strength to the plywood itself. So I decided to use 1x2s, and with the 1x2s, it added 3/4 of an inch to the thickness of each level, but to me it was space well spent. Now this layout is built, like I said, it's built in panels. It is not built as a portable layout or a modular or a sectional layout. But if I ever have to move it, it could be taken apart somewhat because of the way we did the wiring with this. Running the wires through the brackets or under the brackets was not a good idea as far as ever being able to take it down, because the brackets would just be in the way. So I decided to use the 1x2s to support the wood. That opened up a lot of possibilities for me. To get started though with actually building it, I went ahead and on graph paper I drew an outline of the room and an outline of where the fascia of the layout was going to be. Do one of these for each level. Do one of these diagrams for each level that you have. Now note that the uprights are about 1 inch thick, so that's going to make your overall measurement of the room, if it's a layout like this, it's going to make it 2 inches narrower in both directions, and that would affect you more or less depending on your track plan. Okay, and also be aware that corners are not necessarily 90 degrees. Walls are not necessarily plumb or flat, so just be aware of that. You want to put everything together before you actually do anything, and we'll do that as we go along. The next step was to go ahead and take that same sketch for each level and mark the location of all the studs in the wall. That's what those little tick marks are. And I wrote down on my list how many pieces of vertical shelf pieces I was going to need, as well as how long they had to be. Okay, and then again, every stud does not need to have a bracket. So if you have two studs really close to a corner, decide which one you want to have a bracket on, and then just leave the other one off. When I was done with that, I marked the location of where the brackets were going to be. Now, keep the end of the bracket about 4 or 5 inches away from the edge of your fascia, because that's a good place to screw your lighting into. Mark that down, and then the brackets themselves come in measurements varies. For the most part, they're about 3-inch increments. So you want to mark that down. You want to check and see what the different lengths are. I don't know if they're all the same all over the place, but you might want to check your local big box store for that. Okay? Next up was I marked the outline of the layout, and I did this again on all the levels. The dotted lines are sheets of plywood. That represents sheets of plywood, 8-foot long sheets of plywood. And I positioned everything so that I could get the most out of each sheet. And when I had, on this layout, I had all 3 levels. When I was done with that, I had sections that were 1.5 foot wide, another section that was 2.5 foot wide. So that was a 4-foot panel of plywood. So I figured that all out, how many panels I was going to need. When I was done, I had a list to take with me, and it looks like this. I have a list of all the wood that I need. It has how many upright pieces I need and the length, how many horizontal brackets I need, and I would also have how many pieces of 1x2 I would need by adding up these inches times however many pieces, dividing that by 12. And I also want to put a strip of 1x2 around the whole outer edge. So measure that linear feet that you're going to need for that as well. And then I had how many sheets of plywood that I was going to need, and the width or the length that I want them cut to. On the bottom of the list, I also have 1.25 inch drywall screws that I'm going to use to attach all the 1x2s to the sheets of plywood. I used yellow carpenter's glue. Get a big bottle because you're going to use a lot of it. When I did the presentation, somebody said something about some kind of foaming glue. I don't know what it is. So if you know what it is and you want to try that, go ahead. Somebody also mentioned Gorilla Glue, which is like really expensive. And then I also got a good quality exterior wood sealer. Okay? When I got the wood that I used for the sub base is 3/4 inch hardwood sanded plywood. It's sanded on one side. It's a furniture grade plywood. It cost about $10 or so more than what like OSB or chipboard would be, and it's money well spent. I mean, you're going to have a flat surface to work with rather than some lumpy thing. For the 1x2s, I used poplar, and take the time and go through the stock, and don't take any of the twisted pieces or the warped pieces or pieces that are split or have knots in it. Leave that for the next guy. That's time well spent rooting through all that. When we start building, all the screws on here are all pre-drilled and countersunk. Most of the wood-to-wood joints are glued and screwed together. On the ends of the 1x2s that butt up against the back edge of the 1x2s, I glued that whole edge to add some strength to it. The glue is actually stronger than the screws themselves. As I was going along, check to make sure that when you seal or glue anything, that you don't have any drips that are going to be in the way of when you put your panels together or anything like that. I went to the lumber yard and I got everything, and when the reason I had my list of what to cut the wood was, I went ahead and I had them cut the wood to the different widths that I needed, and it saved me a lot of time because I could just take it to them, they take it off, they cut it. It's easier for me to put in the truck and carry it, get out of the truck and all that kind of stuff, carry it in the house, and they do a much more accurate job of sawing a straight line than I can do. I think they charge like 50 cents a cut. Some of the places will give you one cut on a piece of wood for nothing, but I guess that varies depending on where you're at. If you if you can, and you have all your measurements for your 1x2s, you could cut them all to length now also. Before I even brought the wood into the house, I sealed it. And before I sealed it, I wrote, you could feel the difference between the sanded side and the non-sanded side. Mark the sanded side as top, and then I marked the edge that was the factory edge as back. I flipped the piece upside down and I sealed the bottom and the back and the two short edges, and then I sealed all the pieces on the 1x2s. I sealed it all up before I brought it in the house. There's going to be some spots where you're going to have to touch it up later on, but try and get as much of it as you can now. The reason I used an exterior sealer was the guy at the paint store told me that an interior sealer I need to put 2 coats on. An exterior sealer is a much better sealer, and putting 1 coat on and having it in the house is going to do a better job than 2 coats of interior sealer would do. So there's that. Once that was done and I brought the pieces inside, on the back edge of all the pieces of plywood I ran a strip of 1x2, and I laid it this way on the plywood. I laid it horizontally, not vertically. I laid it this way, and I laid it so that there was like a 1/4 inch lip on the back edge. I left that there so that when I put a backdrop in, I can rest it on that. That way I don't have to worry about attaching the bottom of the backdrop to the wall. I already have that lip there. I can leave it in there. Next, I brought the plywood in, and according to my sketch, I put the panels where they belonged, and then I joined them together with what I call splice plates. Here's a picture of a splice plate. It's basically a 12-inch wide strip of plywood, and as you can see, I glued one side on, and I screwed both sides together. When I glued the one side, I made sure not to get any glue oozing out and interfering with the alignment of the adjoining piece. You want to make sure it gets together nice and flush and flat and even front to back. Okay, and as I said, you can see that there's a lot of screws in this, and if it doesn't fall on a bracket, or if it does fall on a bracket, really doesn't matter, okay, because it's there for strength. Once these are in, it was time to start lining up the brackets. These brackets don't move side to side on the bracket. They kind of move like this in a jerky motion. So you want to make sure you want to go ahead and you want to make sure that the bracket is perpendicular to the wall. And here I use a square to line up the bracket from the wall, and I put a dotted line down because this isn't the center of the bracket, it's the outside edge. Okay, I just stopped the line at the end of the bracket, so I knew where the end of the bracket was also. Next up, I marked the center of the holes that are in the bracket because I'll be using those to attach the plywood base to these brackets. And the brackets all have either 2 or 3 holes. The larger ones might have 3. They have one round hole and one elongated hole. So find the center of both of them, mark that on your plywood. Okay? Now the next thing you're going to do is we're going to take the plywood off, flip it upside down, and where you marked those holes, the location for those holes in that last step, you're going to take a drill and you're going to drill all the way through the plywood to mark the location of where the screw holes are going to be. And on the top, you want to mark with an X or a circle or something where that screw hole is. And the reason being, when you're laying the track, if you're laying it over a screw hole, you want to make sure that when you put the screws in to attach this piece down, that you don't end up having your nice track work have something like that come up through it. Okay, that's what we call a bad day. Okay, next what you want to do is you have the center line you have a center line of your bracket here, and you want to mark both sides for where the 1x2 strip is going to go. And the reason I did that It's just that when I started putting the wood together, I just wanted to be able to line it up without having to measure anything or check. And those lines guided me on where to position my wood. Next up was to mark the location of where the screw holes were going to be in each of the 1x2s that were used for the supports. And that's on here, that's those black lines going in. The reason for that is you want to make sure that they're clear. Everything else can, all the other holes that we're going to be drilling can be moved. These can't really because of the brackets. Also in this you'll see there's marks. I drew a pencil line down the center of the wood, and there's X's in here, and that's the location of where I'm going to drill to run my wires through. Okay? And here I drilled a hole through the 1x2 from one side to the other for each wire. There's 6 holes in here, and they're spaced out so that when I put the screw into the bracket, I don't run it through a wire. They're, I believe they're like 1/4-inch holes. It doesn't really matter what size they're because you run a wire through it. But you do want to make sure that when you run the drill through on the opposite end, you want to make sure that the wood just didn't get blown out, so that when you go to run the wire, it's all easier to do it that way. Okay, just to stay ahead of things and be nice and neat with it. Next up, on the 1x2s, I drilled and countersunked them for the screw holes, so that they were nice and flush and they wouldn't interfere with the bracket at all. Okay? And then when we're done with that, we glue the 1x2 on, butting it up against the 1x2 on the back, and we screw it down. You can see here we have the screw hole, the screw holding the 1x2 on. The black marks indicate where the screw to wood bracket is going to be located at, and we have our holes for our wires. So no screw is interfering with any other hole. You're not going to worry about driving a screw through a wire or anything like that. This is obviously upside down, and then when we put it back up on the benchwork, it looks like that. Okay, so it's all screwed down, all ready to go. And you'll notice here, the longer the bracket is, the more here, the thicker this gets. So you're going to need to get some longer screws to run through here, and that's going to, how long the screws are going to be depending on how many of the how long your brackets are. You could just go ahead and buy a box of long ones and cut them off, but make sure you put the screw in the right spot, or else you'll end up with that screw coming up through a turnout. Okay? Once that was all done, I went ahead and I used my track plan. I drew my track plan out on craft paper on a 3-inch square, 3 inches equals a foot plan. I marked the plywood out in 1 foot squares. I took my plan and I laid it out on the plywood, and I laid it out in pencil, and I used the tubes from Blue Point controllers to get nice even flowing curves and arcs. There's really no radiuses, no fixed radiuses on this layout. It's all arcs and curves and things like that. You also might notice, because of the brackets, you may need to move a turnout or like a turntable pit or something like that out of the way, and that's going to depend on how complicated your track plan is. Worst case, you probably could move a bracket depending on what's below it. That's up to it on an individual basis there. Next, I went ahead and I glued the road bed down. I used Homabed on this, whether Homabed, cork, whatever you're using. And you can see I went right over top of the seam between the plywood. The most important thing here to remember is don't get any glue in the joint here. If you do, make sure you get it cleaned out, or just try to be very careful there. Okay? Neatness counts. Next up, I sanded the road bed to smooth it out, and to knock the corner off of the edge of the road bed. And I took a razor saw and I cut the road bed at each panel. Okay? I did that with a razor saw. Next, I marked the outline of the fascia, and I cut that off with a jigsaw. And also on the back edge, I have some inside corners, so I marked out for the curve of the curved backdrop, and I cut those pieces off. When that was done, I took those pieces off. I then went ahead and I sealed the top of the layout, the homosote and all, and I again sealed all the edges and any other pieces of wood that were bare wood that hadn't been sealed yet. At this point, all the wood on the layout should be sealed. Now, when everything's dry, before you go any further, check everything. Check where your splice plates are and your joining wood together, the bottom of your 1x2 where they're going to join the bracket, and the edges of your plywood where they're going to join up. Make sure there's no drips, nothing that's going to interfere with anything when you're done. Now you can take the sections and you can set them on sawhorses, on a table, on a bench, whatever you want to do, whatever you want to work at, whatever a comfortable height is for you. And like this handsome devil, you can work on the layout at a nice comfortable height. If you're still working on the first level, you can put the brackets up, make a shelf on the wall, put all your track laying tools, your wiring tools, whatever you need. When you're done working on the top, you take the panel off, you flip it upside down. You'll get so much more done working this way rather than reaching up and climbing under and everything else. And it's going to result in a lot nicer looking job. And it's going to be more organized because you're not going to be looking upside down at something and thinking that you're looking at it the right way. You're going to end up with something that looks like this. If you notice here that the splice plate is over this side. We have our 1x2 across the back that holds the backdrop up. Obviously this is upside down. Here and over here we have the 1x2s that are glued down. All the wiring runs through the 1x2s. There's only the buzz and the sub buzzes are in place. There's no accessory wires on this. The turnout controls, the Blue Point turnout controls are installed. So there's a turnout above that, and all the wires begin and end at a terminal strip. You'll see some of these wires have crimp connectors on them. The Blue Points are from a previous layout, so if the wires were in the correct spot, I didn't bother undoing them. If they weren't, I took cut the ends off, and I used, these are spade containers with connectors on some of them, but for the rest of them I used loop connectors. You have to take the screw out of the terminal strip and put it through the wire, but I felt that it was one less place for any kind of a voltage drop. And you'll notice that there's all the wires that are connected to wire are all soldered together, as are the crimp connectors. Even though they're crimped, I soldered them together anyway. You will not find a suitcase connector anywhere on this layout. There is, like all things, there's a downside to a multiple level layout. As far as building it, that's it. It's as simple as that. The downside to having a multiple level layout is you're building a layout in a room with a layout already. And every year I have an open house. I invite some other narrow gaugers over, and one time one of the guys commented that my workbench was too clean. You know who you are. So to prove the point, when you're building a multiple level layout, this is what you can end up having. Everything in its place, and a place for everything. Just like that. So that's the end. If you have any comments or questions, or you want to add anything, I'm a big boy. I can take criticism. You can email me. This is my email address. It's HARFROM, from PA, the number 2, @ AOL.com. That's it. Thanks a lot.